Okay, so let's start. Lawrence, you're the only one right now. Maybe other people are going to join in. It's probably too early, but I thought maybe if anyone can join in early, can ask questions, and then let's see who joins probably at 6 o'clock, and then we'll stay until 7. If you have any question, if there's nobody else, and we sort of answer all your questions, and we can close this session. So what I wanted to do with this session today is that I wanted to go over some of the things that we learned in the correlation, and then preemptively answer some of the questions about regression. Okay, Janie. Is connecting. So you still see my screen, right?
Yes.
Okay.
Yeah, I do.
And Melissa. So let's add. Hi, Jenna or Janie. I'm sorry if I'm pronouncing it wrong.
That's okay. It's Janae.
Janae. Okay. None of those were right. So Melissa is here. Yeah. Okay. Let's admit Victoria. Okay. Hi, everyone. So as I was saying, and by the way, I'm recording this. I started just a few minutes ago at 5:45. I'm recording it so that I can put it on Blackboard, and everybody else who can't be here in this session online can have a chance to look at it later on. So what I wanted to do is that after seeing everybody's assignment discussion board, I wasn't totally satisfied, to be honest, and some assignments were missing. I thought after the first 2 weeks, which could be hard because they have 2 chapters each, the third week with correlation would probably start a downward slope in terms of difficulty, but I saw that still there was some issues, and I wanted to hold this session to get some questions from you, and also to show some of the regression tests. We are on week 4 this week, and that's regression. Okay, so before I start, do you have any questions? Maybe a specific question that I can answer quickly? Anything that you found that were lacking in terms of materials or the textbook, and something that was not so easy to understand?
I did have a question, but not about that. I wanted to know if we wanted to follow along, like in front of our screen, what data set this was.
Oh, today? You mean right now?
Yeah.
Well, it depends. If you want to, then yes.
Because I can see it, but I'm using my phone, so it's not as big. Yeah.
Oh, but don't worry about it. I mean, on the phone, you can't use SPSS anyway. I don't think that there is an SPSS app for the phone.
No, but I have my computer in front of me, but the screen on my phone is just small.
I see. Okay. Well, I'll talk about it as I go over these commands. I'll mention their names.
Okay,
right?
all right.
So
thank you.
if you want to follow along, that's great. The data set that I'm using right now is the CRJ716 class survey data set, spring 23. This is the data set, the SPSS data set that I put out there for you guys, to take a look at it and maybe practice. Okay, so so I have, let me admit some more people. I don't even know how many of those right now. Hopefully I admitted everybody. Yeah, 1, 2, 3, 4, 5, 6, 7. All right. One is a Zoom user. Okay, great. Yeah, so you can follow along with what I'm going to be doing here. But in terms of correlation, was there anything specific that was missing in the materials? Anything that you couldn't understand? If there was, just ask me, and I'll go over it. Otherwise, I can, you know, take a stab at doing a correlation test in this data set that I opened up here, which is the class survey CRJ716 data set. All right, so if you don't have any questions, I'll start with the correlation. So we are in this course, because this is a 8-week course, very short semester. We are not going to go into multiple, analysis, which is the use of multiple independent variables or multiple dependent variables. So usually we just do bivariate analysis. So it's going to be one independent variable and one dependent variable. But why do we do this? We are sort of testing the relationship, the association, the correlation, or the difference between variables or groups within variables. Okay, so this is just one of the steps that we learn in CRJ715. In CRJ715, when you go and do a research article, if you go and complete this last step, which is a statistical analysis of the data that you've gathered, then you have a complete research article. And this is the last step, so it logically follows CRJ715. I think I have one more here, let me admit. All right, so what do we do? The easiest things that we do in statistics is just descriptive statistics, right? And after that, we move on to inferential statistics. Descriptive statistics, as you saw, is usually just frequency tables and descriptive, such as, measures of central tendency, such as mean, mode, and median, measures of distribution, such as standard deviation, the variance, and also the normality of the distribution, and that you have skewness and kurtosis and all of that. But we moved on from that. So this is the third week. Now we test relationships, association between variables. Now remember that we have 4 levels of measurement, right? 4. But those are branched into 2 major types of variables. One is categorical variable, right? That is the nominal and ordinal. And the other one is the numerical or continuous variables, interval or ratio. Now, depending on the level of measurement of your variables, you're going to find which is the appropriate test to do. In the correlation, as every chapter's name, gives a hint, we do the correlation test. But now we have to figure out what type of variables are we going to use in order to conduct the correlation test. So correlation test is conducted with the appropriate levels of measurement that are interval or ratio. So the variables that go into the correlation test or are going to be tested using the correlation test are numerical, continuous, or what SPSS here says scale. All right. So what is a research question that you want to know? here, because we can't do correlation with nominal variables. We can't figure out gender and party. You know, what is the, we can find out association between them, but we can't use correlation. We're going to use another test, and that's going to be in week 7. And actually, I'm trying to do another video for this. For correlation, we're going to have to use 2 variables that are continuous in nature, right? Scale variables. And why is that? Because, and I'm going to show you, if, for example, let's say these 2 variables are continuous in nature, they are interval variables, or age is a ratio variable, and we can do a correlation test with these 2. Why? Because for each observant or participant or observation, okay, we have a pair of values. We have a 29 and we have a 3.88. So those pairs of values have 1 dot that can be plotted in a scatter plot. And you've seen that. So this is 1 dot, and this is another dot, and that's another one, and another, and another. So all of these dots are plotted in that particular chart, and then we can see how all of these scatter plot, or all of these values or dots, are scattered around, whether they have a perfect pattern, or maybe they don't have a pattern at all. If they don't have a pattern at all, then we can just eyeball that and say that there is no relationship between these 2 variables. But if the pattern is, say, you know, from lower left to upper right, then it's a perfect positive. And the dots just go and fall on a straight line, right? So that's a perfect positive correlation. And that's all we can do with correlation. Right now, we can just see the values of the age, and we can see the values of graduate GPA. What about other continuous variables that we have here? Okay, we have the social media friends. We have the commute in minutes. Do we have another one? I think we do. Let's go down here. We have the pretest score. And by the way, as you can see, these are not the values from only our class, but it's from a lot of semesters that I've gathered every semester. And these are not even those, because this would go back 10 years prior. So as you see, sometime if I figure out that there is a question that is, you know, worthy of adding it, and that's why I ask you guys. I think the 4th question in discussion board 1 is to say what type of questions would you have asked your fellow classmates. And if I think that some of the questions are worthy of adding here, I would add. And one of those is this, the pretest score of, or maybe would you take another class? You see, or how many hours of study do you think that you're going to study for this class, or the motivation for taking this course, and so on. Anyway, so the pretest score, right? Now, can someone tell me a research question? What do you want to know? Is there anything that you are particularly interested in? Taking into consideration that we need only 2 variables that are continuous in nature, right? Can you tell me a null hypothesis, for example? Okay. First of all, is hours of study a continuous variable?
Yes.
Why is that? I have a chat here. Why do you think that, Taishan? Continuous variables are interval and ratio, right?
Yeah.
So which one is this?
Where are you pointing at?
Say it again, please.
Where are you pointing at? What variables are we looking at?
I'm talking about this, hours of study.
Yes, it's continuous nominal. I mean, not nominal, continuous interval or ratio.
But which one?
It's a interval.
Okay.
There's a true zero.
So the interval, so first of all, this is not continuous. This is a categorical variable. This is an ordinal variable. Why? Because you do have categories that make this, such as 1 to 3 hours, 4 to 6 hours, 7 to 8 hours, or 0 hours. So there are 4 categories that go here, right? 4 categories, 4 groups, 4 attributes. Now, these are different from each other, just like the county. Bronx is different from Westchester and New York and Kings and so on. But the difference between county, which is nominal, and hours of study, that is ordinal, is that there is a difference between the groups, but you can't really say that one is more or less than the other, right? Kings County, for example, I live in Kings County. I can't say that that Brooklyn is better than Queens. Well, if I were to figure out an objective, then probably yes. For example, if I were to measure number of arrests, but number of arrests would be the one that measured, not the county, right? So county as a attribute does not have any difference. Here, hours of study have a difference. 4 to 6 hours study is more than 1 to 3 hours. 7 to 10 is more than 4 to 6 hours, and definitely more than 1 to 3 hours. The only thing that we can figure out here is the difference. So if somebody said that I'm going to study 4 to 6 hours, and another one said here 7 to 10 hours, you can't subtract that. You don't really know, because 4 to 6 hours could be 4, 5, or 6. And 7 to 10 is going to be 7, 8, 9, and 10. You don't know the exact value. That's why you can't make that difference. You can't calculate that difference. Here, for example, in commute, you can calculate that difference. 90 minutes is much more than 50, and it's 40 minutes more than 50. So anyway, hours of study is ordinal, so we can't use that. If for hours of study, I would have asked the specific number of hours that you think you're going to study for this course during the week, and you put 5, 6, 8, 1, 0, that would have been a ratio variable, a continuous variable. So hours of study is ordinal. That's why we can't use it in correlation right now. The only thing that we can use in correlation are these: age, graduate GPA, undergraduate GPA, social media friends, commute, and the last one, I think, the pre-test score. Yeah. We can't even use the statistics undergraduate course grade, because that is an ordinal variable. Anyway, anybody came up with a null hypothesis? What are you interested in figuring out? Is age related or correlated with graduate GPA? Or is age related or correlated with social media friends? Or undergraduate GPA correlated with pre-test score? Maybe that's probably the best. I think it's the more interesting one. What do you think? All right, so the research question would be that the higher the undergraduate GPA, the higher the pretest score. Oh, by the way, Taishon, here's another thing here that you can see. If you go to variable view and you see hours of study, well, ordinal is something that I put there, but when you look at the values, you see you have a value 1, 2, 3, 4, 5. Those are for categories, right? Or for attributes or groups. And you have a label. So 1 is 0 hours. If somebody answered 2, they'll do 1 to 3 hours. Okay, and we do this because SPSS can't work with string variables or characters. So for example, if we'll put 0 hours or 1-3, SPSS is going to take that as a 2 because, or -2, because it's going to subtract 3 from 1. And this is going to be also -2, and this is going to be -3, and so on, right? Look, maybe I branch out a lot to show a lot of stuff, but just stop me when I go on and on. Anyway, going back to our research question. So I think that the pretest score is going to depend on the undergraduate GPA. If the undergraduate GPA was high, the pretest score is going to be high. And if it was low, then the pretest score is going to be low. So somebody who didn't have a high undergraduate GPA did not as well as somebody who had a high undergraduate GPA in pretest score. So that is a research question. Now, to tackle that, we have to create a fictitious hypothesis, which is the null. And the null hypothesis says that there is no correlation between undergraduate GPA and pretest score. So the correlation coefficient is 0. So if we plotted those values and those dots in a scatter plot, we're going to see them all over the place, meaning that we don't see a pattern. As one increases, the other does not increase or remains the same. All right. So, and the alternative hypothesis is going to be that there is a correlation between these two. We're not going to say that there is a positive correlation or a negative correlation. We're just going to say that there is a correlation, so that it's a two-tailed hypothesis. We could capture, the possibilities that as the undergraduate GPA goes up, the pretest score also goes up. But it captures the possibility as well of whether the undergraduate GPA goes up, the pretest score goes down. Okay. And we're going to test this at the significance level of 0.05 or a reference probability of 5%. To do correlation, you go to Analyze menu, click on it, and then the menu drops down. You find Correlate towards the middle of that menu, and then select Bivariate. We could do bivariate with confidence intervals, but we can check confidence intervals in the bivariate as well.
Sorry, Professor, can you repeat what you just did?
So I went to Analyze. Can you see my screen?
Yes.
Okay. I don't think that there is a way that I can make this bigger, to be honest. No. Control plus doesn't work.
Oh, I can see fine. I just missed the steps.
Oh, okay. So Analyze, Correlate, and then Bivariate. So once you click Bivariate, then you see the Bivariate.
Why you say we don't choose bivariate with confidence intervals?
Right. I didn't choose that because I can choose confidence interval right over here if I wanted to. But right now, I'm not interested in the confidence intervals. I'm just interested in the correlation coefficient. Okay, so that's the main thing about the correlation test, is the correlation coefficient, a Pearson correlation coefficient R. And that is also the size or the effect size of this relationship, all right? So we're gonna test this at 0.05 confidence level, but at the same time, we're gonna get the correlation coefficient. Okay, and then we're gonna see some things with this test, and I'm gonna go over them. So in the bivariate correlations on the left side, you see all the variables in the data set. Sometimes you don't see all because some variables are hidden since they are not the appropriate measurement level to do that test. And not in this case though, but in some other tests, you probably are not going to see those variables or some variables. So here we're going to find undergraduate GPA, click on it, and then with the arrow, bring it into the variables box. And then we're going to get pre-test score. You can just click and drag. Okay, so now once you have the two variables in the variables box, okay, that means that we're going to test the relationship between these two variables. Okay, in the correlation coefficients, you can leave Pearson. That is selected by default. What is the other two? The Spearman and Kendall-Taub are if we don't assume equal variances for these two variables. So you see, in order to go to correlate to the correlation test and regression test and t-test and ANOVA and chi-square and all that stuff, we are assuming that you've done your due diligence and you've done the test for normality, you've done the frequency test, you've done the not the frequency test, but you found out, you know, the frequencies, you found out the measures of central tendency and dispersion and all of that stuff. So it's assumed that you know everything about these two variables. And when you know everything about these two variables individually, then we have some assumptions. And those assumptions are that these two, we found out that these are normally distributed. And that's why we use Pearson, okay? If they were not normally distributed, the variances were not normally distributed, then we can use Spearman. But anyway, Pearson is fine. You know, it's a robust test. Did you understand what I just said about, you know, doing all of the work before? That is very important. So the test of significance is a two-tailed test. If our alternative hypothesis was one-tailed, or let's say one-directional, so that the higher the undergraduate GPA, the higher the pre-test score, then we can do a one-tailed test. But we said that there is no correlation, so it could be either positive or negative. Here, we're going to flag significant correlations. What does that mean? You've seen those little asterisks, right? That is to flag whether that correlation is significant or not. By the way, I haven't done this test, so I'm really curious to see whether, you know, what comes out. In the options, okay, you can get some statistics, but if we had done, you know, our univariate analysis before, we wouldn't need to do that, but I'm going to do it now. I'm going to get means and standard deviation. Bootstrap, I'm not going to get it. So for example, confidence interval, let's not go into it for now. In my video, I go over it, confidence intervals a little bit. Anyway, let's click OK. And now we see the output table. All right. See, the descriptive statistics, the mean and standard deviation, all right, were, I'm going to go to here. That shows me all the most recent commands. See, in the options, means and standard deviation, that option gave me this descriptive statistics table. So the mean for undergraduate GPA for all students was 3.5. And the mean for what score did you get on the pretest on statistical knowledge is 7.9. Standard deviation is respectively 0.3 and 2.9, okay? There are 423 students who answered the undergraduate GPA and only 42 answers for the other pretest score question. All right, the most important thing here is the correlations table. What do we see? Generally, when you have a bivariate correlation table, you're going to have a matrix like this. So if you go diagonally, you're going to see a correlation of 1. That means that the variable correlated with itself is always going to be perfect 1. Okay, but we don't need to see that. And that's why I stress the APA table. In APA table, we would get rid of one of the columns and one of the rows. So we'd have only these 3 values. So the first thing we see is the Pearson correlation coefficient is 0.194. Now the correlation coefficient goes from -1 here, -1 to +1. All right, -1 and +1 are the strongest perfect correlation, but 0 is no correlation. So right here we see that this is a positive correlation, which means that as one variable, the undergraduate GPA increases, so does the pretest on statistical knowledge. So right here we can see that that does have some effect. Okay, is it strong? No, it's 0.2. It's relatively weak correlation. And if we go to the significance, that is the p-value, which we use to test the null hypothesis. Remember that the significance level was 0.05, okay? And if our p-value is smaller than 0.05, then we reject the null hypothesis. But if it's greater, then we fail to reject the null hypothesis. Remember what the null hypothesis were? It was that there is no correlation between undergraduate GPA and pretest on statistical knowledge. So because we fail to reject, we retain it, we keep it. So this test does not give us enough evidence to state that there is a significant correlation between these 2 variables. And we can see that the strength of this relationship is weak, or relatively weak. Okay, so that's all you can see and say here. Then you have to definitely report this in APA style. Now we can do something else with the graphs.
I just had a
Go
quick
ahead.
question. When changing the table to APA style, you have to do it manually, correct?
Right.
Okay.
Right. So you copy this. And let me open a Microsoft Word document. And then paste it. So what you can do is take this and put it over here. Okay. And delete this column. Select, right click, delete cells, and then you say delete entire column. And bring these 3 here. Okay, so this should be Okay. And you delete this row. Delete these rows too. And this is it. So you just say table 1, and then the table name, correlation between X and Y.
Professor,
Okay. Thank you.
I have a
You're
question actually. What
Yes.
makes this APA format different than the APA format that's already embedded into SPSS?
Well, they have not sort of followed the APA guide 100%. For example, for correlation, they have not. Okay, and you should know that that table that I just created, that I removed, is simpler, and it doesn't have all of this junk here. That I don't need this here and this here. Right, so you have to make your table smaller and easier to understand. For frequencies, for example, let me show you really quickly. Descriptive statistics, and you get frequencies. See, you have this option here, create APA style tables. This wasn't there before in the other previous versions of SPSS. So let's get gender, for example, and then let's select create APA tables. Bring gender here, click OK. See, what is your gender? So this is fine, for example. You just have to add table 1 or 2 or whatever, table 2, what is your gender? And then this is good. If I did it as non-APA style, then you would get a little bit more. So what would you get? You would get the percent and the valid percent and cumulative percent. So in this case, SPSS is correct in following this APA style on this table, but not on, for example, correlations. Correlations didn't have the table APA style. Do you see?
Yes, thank you.
Yeah. All right. So I was going to go to graphs, chart builder, and I'm going to create a scatter plot. So I'm going to select the scatter dot from the gallery here, the simple scatter plot. Once you select that, you drag and drop here in this area. Do you see this? Drop it there. And now you bring in the x-axis is the one that you think is the independent variable, the one that you think affects or impacts the outcome. And that is the undergraduate GPA. Bring it over here. And pretest score goes into the y-axis. By the way, don't rely on looking at this. This is just a template. It's not the right thing. You can change the chart appearance and all of that stuff, but for now, I'm not interested in that. So let's look at this. All right, so I can see a small pattern here, very, very small, very small. Okay. Mostly it doesn't change. Okay. These two here, for example, who have a 3 undergraduate, a GPA of 3, they do have, didn't do so well, to put it mildly, in the pretest score. Okay, so if you didn't have these, for example, these 3 values, then maybe there would have been a 0 correlation. I can select those and remove it and maybe check it out later, but yeah. So without these 3 values, it looks like it's flat. These 3 values are weighing down, meaning that it's bringing the lower portion a little bit down, therefore giving it a sort of a diagonal shape, just a little bit. All right, so you don't really see much here. If you were to guess, did you take a look at that a link that I put on the lessons, guess the correlation coefficient? So if you worked with it a little bit or played with it a little bit, then you would have probably seen that this is almost 0.2. Okay, and if you said 0.2, you'd have been right. Anyway, I can do a fit line here, and look how the fit line goes. It's not from the lower left to upper right, meaning from the minimum value to the maximum value of the y variable. It's somewhere over here to here. All right, this is important for one reason. I don't know if you can see this. R square linear is equals to 0.038. What is this? This is correlation R squared. So if you square 0.194, you're gonna get this 0.038. When you translate that into percentage, what is the number? What is the percentage? %3.8%. So what that means is that the variation in the undergraduate GPA explains only 3.8% of the variation in the values of the pretest score. Almost nothing. So the other 96.2% is explained by other variables. And that shows you that it is not significant. Okay. And this is what you had to do in discussion board week 3 to figure out whether drinking tea, improves your cognitive score. Do you have any questions on this? Okay, so moving on to regression. We're going to use the same two variables, undergraduate GPA and pretest score. So with regression, now you move on further down the analysis of these two variables. Not only you can see how they are correlated, which we did, but we can sort of predict what is the pretest score going to be for a given undergraduate GPA score. Okay, so how does that happen? The regression test, relies on some more mathematical formula calculations, and I'm going to show you how that's done. By the way, did you guys have a chance to look at the regression video I put out there on Blackboard? Not yet? All right.
I was able to. Yeah.
Okay. Was there anything that you wanted to know and the video did not cover it?
No, it goes really well with the handouts or the lectures too.
Okay,
So.
great.
I didn't have a question about the regression portion, but for the correlation portion in the response that you sent us with the correct answer, there was a section that included the bootstrap option.
Right.
Can you kind of explain that a little?
Okay. The bootstrap option is just optional at this point. Okay, you don't need to do it. And I did not, you know, withhold any points for anyone because of that. And anyway, nobody had done the bootstrap option, but you don't need to worry about that. The bootstrap option, just very quickly, when you go to correlate bivariate, and then you do the bootstrap, right? When you perform a bootstrap, just from here, SPSS is going to get 1,000 samples that are similar to these, the data that we have here, and perform the same mathematical calculation. And then figure out how, you know, those other samples are going to compare with this sample, given a 95% confidence interval. Okay, so that's all it does. If you want to do a stratified sampling, you know, then you can enter one more variable into the mix and stratify that relationship between the initial two variables among the groups of the other variables that we're stratifying. But you don't really need to do this. You know, let me just show you very quickly.
Oh, okay. When I saw it in the response, I was like, wait, I totally missed something.
No, don't worry about it. What you saw is this. Yeah. So the bootstrap just gives you the 95% confidence interval with the lower bound and the upper bound. Okay, including those 1,000 samples that SPSS automatically and fictionally created. Okay, but it doesn't change anything. The correlation coefficient is still going to be based on the data that we have in our sample. All right.
Okay, thank you.
But I think, thank you for doing this, because yeah, I said I'm not going to put the confidence interval because it's in the video, but it's good to just show here just a little bit. So what does this mean? Generally, and you know, keep this in mind, when the lower and upper bounds are two different signs, so one is negative and the other is positive, it means that it's going to contain that 95%, right, interval is going to contain 0. And if it contains 0, it means that it could go either way, meaning that 95% of those samples, 1,000 samples, right? So 95% is 950 of those samples will contain 0. And that means that 950 of those samples could have the dependent variable go either up or down, meaning that the pretest score could increase or decrease based on an increase in the independent variable or undergraduate GPA. If these two are the same sign, either positive or negative, then it's going to be either an increase or decrease in the dependent variable with an increase in the independent variable. And that would show generally that there is a significant correlation. Now, because it contains 0, that's why this is not significant, because we can't really say that with the increase of the GPA, the pretest score is going to increase. We can't say that. It could decrease too. Okay, and that's why the p-value generally is bigger than 0.05 when the lower and upper bound are different signs. Does it make sense?
Yes, it does. Thank you.
Great. All right, so let's go to regression. Regression now is a little bit more complicated. You go to analyze regression. Regression is just under correlate, right? So correlate is here, regression is here. in the middle of that analyze menu. And now you go to the second option, linear. Okay, we have two variables. We're going to use linear. We can use multiple independent variables and still use a linear regression. So click on linear, and in the linear regression, you have to select your independent variable and dependent variable and put in the respective boxes. So independent variable goes into the bottom box, which is undergraduate GPA, sort of impacts pretest score. That goes into the dependent. Okay, what do we need here in the statistics? Do we need the descriptives again? Yeah, let's get it. Collinearity diagnostics is very important when you have more than one independent variable. Maybe I have time to show you a multiple regression. R squared change, let's get that. Confidence intervals. Click continue. In the plots, I don't need any residuals, which is the differences. In the options, it went into this. So in the options, you have, the option to change the significance level, but we're going to keep it at 0.05. And that's it. I'm going to click OK. And regression starts over here. So descriptive statistics, we saw that before, right? The mean standard deviation. Correlations table, we saw that before too. 0.194, didn't change much. Significance 0.109, and now it changed a little bit. Did it change? Correlation? Yeah, it did. Significance before was 0.218. Now is 0.109. Okay, it is still greater than 0.05. Okay, I figured out why the significance is different from the correlations. In the correlations here, we did not ask SPSS to remove cases pairwise. For example, you see that, for example, these observations here only have undergraduate GPA, but do not have pretest score. So in correlation, we have to remove this if we want to have the same as the correlation table in the regression, because the regression automatically removes those. Remember, we had here linear regression. In the options, we are excluding cases listwise. So this is listed as one case, and we exclude that. And now, in the correlations, here we had 423 cases for undergraduate GPA and only 42 cases for pretest score. But in regression, we only have 42 cases for each of those. So regression tests exclude the cases listwise if one variable is missing a case. It's great to show you that. And that's why the p-value is different. Still non-significant. Okay, let's move on to the regression, the other regression tables. The variables entered are your undergraduate GPA. This is your independent variable, and the dependent variable is a pretest score. So it tells you what method you used for regression, and that is the enter method. Model summary, okay, has the R and the R square. We saw them before. 0.194 is the R, correlation coefficient, and coefficient of determination, which is the R square, 0.038, 3.8% variation is explained by the independent variable. Now, keep in mind that this is adjusted R square. This is very important when you have multiple independent variables. If you have more than one independent variable, you have to present in your report this value, adjusted R square, not this. Okay, right now it doesn't really matter because it's only one, so you can present the R square that you see here. But when you have multiple independent variables or predictors, you present adjusted R square. Forget about these other things for now. The ANOVA, also leave it alone for now. We're gonna what week 6, we're going to talk about ANOVA. Okay, now we're going to go to the coefficients regression table. There are a few things here. The first row is the constant. The constant is also the intercept. That's what it's called. The constant value, and in the regression equation, is the letter A. Okay, the constant here is 1.090. Let me show you exactly what that means. Here we have the formula, the regression formula, right, in the scatter plot. Y is the dependent variable, equals A, or the intercept, plus B, or the slope, times independent variable value X. Okay, so in this case, if no, not this one. Oh, forget it. I'm going to do it again. Okay, I was able to remove that. So what that 1.9 is, Y, I'm going to do 0. Close. So 1.9 is usually the line where the intercept intersects the y-axis. So it's supposed to be somewhere over here. So if it's 1, 2, if I do close y, major increments, lines, labels and ticks, grid lines. So right here is 2.5, 1 is somewhere over here. Okay, so that line, the intercept, intersects the y-axis somewhere over here and then moves up. Okay, so that's all it means. Yeah, this 1.09. So that means that when the undergraduate GPA is 0, somebody is going to have a pretest score of 1.09. Okay, your undergraduate GPA, of course, is the independent variable, but this B value here, the unstandardized B value, is the slope. We call it the rise over run, meaning that for 1 unit increase in graduate GPA, so from 3 to 4 or from 2 to 3, people are going to have an increase of 1.9 in the pretest score. So if somebody has a score of a GPA of 2, right? If it goes to 3, then if their initial undergraduate pretest score was 12, then it's going to go to 13.9, because 12 plus 1.9 is going to be 13.9. All right, so this is all it means. For 1 unit increase in the independent variable, this much increase in the dependent variable. If this was a negative, then for 1 unit increase in the independent variable, you're gonna have that much decrease in the dependent variable or the outcome. This standardized coefficient beta is also important, because this is the increase in standard deviation for 1 standard deviation increase in the independent variable. So for 1 standard deviation increase in undergraduate GPA, you're going to see a 0.194 standard deviations increase in pretest score. All right. Then these are the t values. There is a special formula to calculate the t value. And based on the t value, we get the significance, the p value. The p value, don't worry about this, the top one. The lower one, 0.218, we saw it before, is a p value of that is greater than 0.05. Therefore, we fail to reject the null hypothesis that there is a significant relationship between these two variables. The null hypothesis that there is no relationship between these two variables, and therefore we can conclude that we can't say, we don't have enough evidence to say that there is a significant relationship between graduate GPA and pretest score. So it doesn't really matter, statistically. It may matter a little bit practically, because it shows that the higher your GPA, the higher the pretest score will be, but statistically that is insignificant. Now, one other thing that I want to mention is that just because something is not statistically significant doesn't mean that it's practically significant. And that's why we do have effect sizes. And in this case, the effect size is the correlation R coefficient, and that is 1.94. 1.94 is relatively weak, but it's not 0. So there is something. It could practically change somebody's grade, could be from, in terms of the pretest score. All right, it could elevate that to the next level. You never know, right? So make that distinction, that just because it's not statistically significant, it doesn't mean that it's practically significant. All right, so the conclusion here is to go back to the graph and construct the regression equation. So you're going to be asked to write the regression equation in your discussion board. So you write it this way: y equals a, which is the intercept, plus the value of the slope or regression coefficient times x. And the question would be, like I said before, if you have, for example, to predict, right, the pretest score. If you have a undergraduate GPA of 3.48, what is your pretest score going to be? You just go to the graph, and then you have 1.09 plus 1.93 times 3.48. So 1.93 times 3.48, then you add 1.9 and you get the pretest score that is going to be predicted if your undergraduate GPA was that value. Okay, let's go over multiple regression really quickly, because I think I'm going to ask you for multiple regression, how to do a multiple regression. I'm not going to show you the one that I'm asking in the discussion board, but I'll show you a different one, a different method. So
You could if you want to.
No, I'm gonna put this on Blackboard for people to see those because I had a few students who said, can you please post it? And I said, yes. So anyway, I mean, look, guys, when I say that, please reach out to me, I really mean it. So just reach out to me, send me an email. All right. I'm available. I may not respond right away, but I will make the utmost effort to respond within 24 hours, definitely. Okay, but I may not respond to all of you on a Sunday, because that's when I get most emails. Don't leave it for a Sunday. I know that that's Parkinson's law, that the more time you give somebody to do to perform a duty, they're going to take that much time and going to do it at the last minute. So, you know, it's a law in nature. What can you do? So I did say that in addition to the undergraduate GPA, maybe there's another variable that can predict that the outcome too, right? So we are in a quest to find the cause, right? To find the cause of these outcomes, and we can't really find that. And that was another question in correlation: business applications causing arrests in New York City. I would suggest that that is not the case. You know, I don't need to see a significant correlation for me to know that that's not the case. Okay, unless, you know, businessmen are causing the arrests, which they can be. But there are other rival causal factors. And also, we needed to find out which one comes first. Maybe the arrest was recorded first and the business application was recorded later, right? So the three-pronged of resolution of causality that we learned in CRJ716, 715. All right, let's say that, I don't know, maybe the more friends one has on social media, the more distraction that person has. Therefore, they couldn't do a perfect pretest score. So let's see. So we're going to add social media friends and maybe graduate GPA too. I could add age as well. So let's do all of those. Analyze. So we go to analyze menu, regression, linear. We do have undergraduate GPA, right? So we're going to add age. We're going to add graduate GPA. And we're going to add social media friends. All right, so how many we have here? 1, 2, 3, 4, right? 4. 4 independent variables. Statistics, we're going to get collinearity diagnostics. What is this? This is a test to find out whether or not these independent variables or predictors are correlated with each other. Because if they are, then they shouldn't be there. Only one of them should be there. Okay, if undergraduate GPA is correlated with graduate GPA, for example, those are 100% correlated, then only one of them is going to make a good predictor, not both. All right, so we're gonna click continue. We don't need the no, yeah, I need the descriptions. Continue. Everything else is fine. And I'm going to leave the method as enter. I don't talk about these, but I just mentioned quickly in the video what these are. The remove is just going to remove all of the independent or predictors that are insignificant, but I don't want to do that because I want to have more control over it rather than SPSS. By the way, the textbook has a real good explanation of what these are. So read that. Okay, click OK. And these are the descriptive statistics. Correlations. Let's see. All right, what is the highest correlation here? It's how old are you with pretest? So age is correlated the strongest with pretest score than any of these. And as expected, the number of friends on Facebook or Instagram is negatively correlated with the pretest score. So the more friends you have, the lower your score will be. The graduate GPA is correlated fairly okay. Your undergraduate GPA, we already did that. So it's 0.247 now. Why? Because the numbers, the values have changed. All right. Variables entered, those are the independent variables. All right. So we do have a improvement in the percentage that the independent variables explain in terms of the variances. So from 3.8% now it's 17.6%. But still, even with these variables, we have more than 80% unexplained. So there should be something else. So even these are not the causes of the pretest scores. Okay, let's look at now the coefficients table. The coefficients table. Oh, this is something for you to look at. The eigenvalue. Okay, this is something that that you have to look at. And what that means in terms of the collinearity diagnostics. Anyway, let's go here. In the significance, we see that only age 0.03 is significant because only that p-value is smaller than 0.05. All right. All other p-values are greater than 0.05, so we retain the null hypothesis, saying here, based on the significance, is that only age is a significant predictor of the pretest score. Okay, and then you write it in a correlation, Pearson correlation, and then the sample size, and then the significance, p smaller than 0.05, or you can write it as p equals 0.03. As you can see, your undergraduate GPA now is kind of closer to 0.05 as it was before. Remember that before it was 0.2, was larger. So it means that these other variables sort of help distinguish that undergraduate GPA is one of the strongest independent variables, but still not significant in terms of statistics. Okay. How do we construct the regression equation here? Unfortunately, we have to remove all of the insignificant predictors, and the only significant predictor is age. So we have to do equals, y equals 0.101 plus, minus 9.101 plus 0.101 times age. So if somebody is 30 years old, for example, we'll have an X independent variable, but if it's 31, then it's going to go up this much, 0.101. So if a 30-year-old had a 12 pretest score, a 31-year-old will have a 12.101 pretest score based on this regression test. Is there anything that I said that you did not get? Okay, Tashon asks, what is a good way to remember what test to perform based on the variables for the exam? There are a lot of different tests, and each has to meet a certain specific criteria for you to be able to successfully run them. Yes, but so that's why we go over each chapter. So we go to correlation. We know that those two are continuous variables, interval and ratio. Regression, the same, interval and ratio. So once we are finished with these two chapters, we should remember those, that those two tests only have interval or ratio variables, which are continuous or numerical variables or scale. Okay, so after week 4, we should be able to remember that. Then when we go to week 5, we're going to talk about the t-test. That is one categorical variable and one continuous variable. The same with ANOVA, but the difference between t-test and ANOVA is the number of groups in the categorical variable. All right, I'm not going to overload you with that, but just remember that after each chapter, you can even make a diagram if you want. Okay, correlation, regression, two variables that are continuous in nature. Then t-test, 1 and 1, and then categorical, chi-square, two categorical variables. I think a diagram would be probably best. Any other questions? Okay, so if you don't have any other questions, then we're going to stop. I'm going to put this on Blackboard for everybody to see. I don't know if I can probably edit this video somehow. I don't think that there was anything to edit, but
when will you post the midterm?
okay, so we are in the week of midterm. The midterm is going to be posted either the last day, Sunday, but probably I'll post it on Saturday so that everybody have 2 days. Probably post it on Saturday.
So we won't have a week to complete it. It'll just be 1 day.
Well, you don't have a week to complete it. You only gonna have 5 hours. Once that's open, you only have 5 hours to complete.
Because you say you're gonna
5
post on
hours.
either Saturday or Sunday, but for both days I work 10-hour shifts. I mean 12-hour shifts, so I won't have time to complete it.
You won't have time to complete it on Saturday and Sunday?
Yes, because I work 12 hours on the weekends.
Okay, that's something to consider. Okay, thanks for letting me know. But my reasoning for not making it available before is so that everybody, finishes up the assignments for the week and then concentrates on the midterm. Because if I make it available, let's say Friday, and people have not yet, finished up their weekly assignments, everybody's going to be confused. But we'll see. I'll accommodate you. It's good to let me know these things, okay? Whenever possible, just shoot me an email and tell me. Okay, so any other questions? All right. Thanks, guys, for joining me in this session. Let me know if you need any other
Yes,
things.
someone asked if we could do these meetings every week.
Can we have another one of these meetings this week? But if we have any of these meetings this week, then it's going to be for the same things that we covered now. Do you have any specific questions for this? Because I would love to do this, but I also have other arrangements, and it's hard for me to figure out whether or not I can have time. So if you have any questions, just let me know now. Every week, once a week. Well, we'll see. We'll see.
Well, for me, I meant if we could have another one of these for this week, being that we have the midterm. I know personally I've been having some struggles just with the class overall and grasping material from week to week. This I wasn't prepared for this meeting today because we were told today that the meeting was happening. So I don't know if maybe we can schedule another time, whether it's for the midterm or just for future reference, or we can schedule one-on-one time, but I just have to go over some things myself to figure out what I really need to work on and focus on. So then I can come to you with specific questions because I don't want to waste your time.
Right, I see. And what is your name, please?
Nicole.
Nicole. Okay, because it doesn't show here. It shows as a Zoom user. All right. Well, I can't say this week. I will try my hardest, but also, well, I will let you know. I can't commit to that just yet, and because I have other things planned. That's why sometimes it's today for tomorrow, or even today for today. That's why, when I have time, I want to dedicate to you guys, then I do it. But if I don't, then I may not. So I will let you know if there can be some available time this week. All right, and that's why I do have these videos, so that it's the same thing that I go over in this session. So take a look at those videos. All right, I put some time and some energy into those, and it's the same thing, even better, because I do have notations and stuff like that I put in the video, and it's easier for you to go back and stop and re-watch and all of that stuff. All right, guys, thank you for joining me today, and good luck. Let me know through email or for anything you need. Bye.
Thank you.
Thank you.
You're welcome.